Hello and welcome to another Solana tutorial. Today we're gonna talk about token ACL, a way how you can do whitelisting and blacklisting of wallets without needing to implement the transfer hook. Because the transfer hook is A, complicated, B, a lot of protocols block tokens with transfer hooks because it could be anything. So having a clean way of doing whitelisting and blacklisting can be super helpful. Why would you need that? Well, maybe you want to do some kind of KYC or some kind of only a certain group of people is allowed to work with this token. Or you want to do the opposite and say, I know a few people that don't want to work with this token, or a few protocols. Or maybe you want to say, I'm okay that users work with this, but programs shouldn't work with it. All of that is possible with token ACL. So today we're gonna have a look at it in detail. Cause guess what? Jonas did of course already make a video about it. Look, this guy. Not this guy. This guy. And again, if you want a quick high-level overview, watch Jonas's video. We're gonna do more of a deep dive, because I want to look at it from a technical perspective with all the nitty-gritty, how it actually works kind of things. But maybe let's start with the problem that it wants to solve. So yeah, KYC AML, as already mentioned, block sanctioned addresses or restrict token transfers to only approved parties. Yeah, all of that so far could not be easily implemented. Token 2022 has the default account state, and that allows you to do this basically. But it's a bit annoying. It's like not great user experience. But the core idea is the same as what we're gonna use with ACL, which also means token ACL only works with token 2022's default account state. Therefore, your token must be a token 2022 token, so a token of the new token program. This does not work for regular token CAC tokens. We should also mention that in the beginning. Yeah, so why default account state? Because you can set it to frozen, which means whenever anybody creates an account, it's frozen per default. And a frozen account, you can't do anything with it. And that means nobody can transfer a token unless they got unfrozen. And that's how that would work the traditional way. So all of the accounts are frozen, and then you have to individually unfreeze all the token accounts of the people who are allowed to use that token. And if you don't know who those are up front, then the users have to contact you and say, hey, please whitelist my wallet. And then you have to manually check, are they allowed to use the token? And if so, you unfreeze their frozen token account, which, is not ideal because it takes time. It's not good UX. You have to do a lot of manual work, and also you have to send the transactions to thaw all the accounts. So it's like, not ideal. So therefore, they've created token ACL, and it works similarly, just that now we'll get a permissionless thaw, which means you don't need to thaw the token accounts. The user can do it themselves based on some criteria defined by a gate program. So the gate program is the gatekeeper to unthawing token accounts. So in the beginning, it works the same way. All of the accounts are frozen, but then instead of texting you at the support, the user calls the ACL program, which invokes the gate program, which does the checking whether the user is on the allow list, then it's fine. If it's on the block list, it stays frozen. By the way, side note, if it's on both, then the block list is stronger, I think. Yeah, so if it's on the block list, then it stays frozen either way, even if it was on the allow list. And there's a different mode that allows all non-PDAs, and if it's a regular user wallet, then it will also just thaw this one. And so that way, the user can instantly get their account unfrozen and then instantly work with those tokens, which is great UX, instant self-service. Is it great UX? It's certainly better UX than what we had before. The user still needs to call this permissionless thaw, but it's not going to be really the user calling that. It's the application that works with those tokens will have it implemented that that's automatically done. So to the user, ideally, they don't even need to know about this flow. For the user, it should just work or not work if they're not on the list or if they're on the block list or whatever. Yeah. Okay, what do we have here? We have an example by Jonas for exploration and educational purposes only. Yeah, this video is also just for exploration and educational purposes. And the actual program is available here and the gate program here. And those are by Solana Foundation and they, I think, got audited. Let me quickly check. Nope, it doesn't say anything about this being audited. And maybe audits are in progress or they don't do anything. I would assume though that for an implementation like this, they would do audits. Anyway, don't find information on that. So for now, use at your own risk. The ABL, allow blocklist gate program used in this guide is a reference implementation while it's audited and production ready. So, okay, this one is audited and production ready. So then the other one is also audited. Issuers are free to create custom gate. And that's, I think, what we're going to do in the next video. We can build our own gate programs. You're only bound to the ACL specification, not the gate program design. Do not use this code directly in production without comprehensive security audits, proper key management systems, regulatory compliance reviews, and legal consultation. Yeah, if you're actually handling value with this, obviously you want to have those things. But we are just playing around for it for now. This is just educational. Okay, then we compare the traditional default account state to token ACL, where user experience is seamless. Again, I wouldn't say seamless, but I would say much better than poor. And we do have an SDK available for that. That's cool. And it's fully composable with other DeFi applications. So that's great. Now let's quickly compare that with transfer hooks. Because when you would do a transfer hook, you could also do that, right? The transfer hook could always check your black or white lists on every transfer. But then for one, you would need to have a transfer hook extension, which again, some applications don't support. And you would check it on every transfer, which is maybe a bit too much. With a token ACL, you would only freeze and thaw it once. And then it works regularly like any other token. So there's no overhead on the transactions. And regular transactions don't need extra accounts like they do for transfer hooks, which makes the transfer hook extension so annoying to work with. But obviously there's things that you can't do with token ACL that you can do with transfer hooks, like royalties and custom transfer validation or whatever. If you want to do something every transfer, then you'll need transfer hooks. But this is just for access control lists. There we go. Complexity for users is low, not zero. It's not seamless. It's low. Okay, good. You can use ACL and transfer hooks together as well. Yeah, that's true. Okay, so let's look at the architecture and then we start actually implementing some stuff. We've got the token ACL program. That's the main program that manages all the freeze and unfreeze. So basically the permissionless thaw. And the gate program, that's the one deciding whether the permissionless thaw should go through. So that can be your custom logic or the ABL gate program implementation. And the mint config is a permint configuration that stores settings and delegates freeze authority. So we have a regular token 2022 mint that delegates to that mint config, which belongs to token ACL. So that seems to be one PDA from token ACL. And then when you do a permissionless thaw, the token ACL program calls the gate program, which checks the user wallet against the allow and block lists or the other configuration that it might have, and then allows a permissionless thaw or not. So let's have a look at the programs. There is the token ACL, so that's the main program. And then there's an implementation for a gate program called ABL gate program. That's just one possible gate program that has those four modes. Either we allow or we block or we do both or we allow non-PDAs. And I would say let's just have a look at this. Let's create a token with a default account state to frozen and then set that token ACL program as the freeze authority and just see how we can work with this. That's a lot of dependencies, but I'm going to install them. So we have Solana program token 2022. So that's the new token program. We've got the token ACL SDK. So that's the main program. And then the ABL gate program. I think that's this one. Cool. Let's create a quick script as we usually do. I'll call it create token. That's the token issuer. We throw away the stuff from the previous video where we worked with subscriptions. If you're interested in that, check it out. And let's do Solana keygen grind starts with ISS, the International Space Station. For the issuer, what fuck the, yeah, take it there. That's the issuer, and I'm gonna transfer to Sol there. Hello, unfunded recipient. It's my personal airdrop. Oh, and then let's do an token. ACLT. Call this the mint key pair, or just the mint, whatever. Good. So we have an issuer with some Sol and a mint. Let's revisit how you create tokens with token 2022, because that's not trivial, because it depends which extensions you want to use. So I knew how that worked once, but we'll figure it out again without using AI. The mint size will be get mint size, and that takes extensions. So that thing must be extensions, and those, they're always needed to put all of the details in there. So I need to have a extension default account state, for instance. Yeah, we have an issue with getting the types here. Okay, let me check here. For the default account state, the data is default account state, which is, it has a state account state. So this needs a state account state, and then I give you the default state. And this is just for those extensions. I'm not actually writing it yet. It just takes those extensions to get the size, so it doesn't matter what I put here, but then we want to write frozen. That's just how we gotta do it. It's a bit weird. And if we wanted to do another extension, we could, let's say I do another one. For instance, I want a metadata pointer. We could add those. Token metadata. But what did I just want to do? I want to be able to recover the mint close authority. That's what I want. Just in case I create the token the wrong way and then I want to recover this key pair, I want to be able to close it. This is not necessary for a token ACL, but I want it because I can. So we're gonna again do search for the mint close authority, which takes just the close authority, which is an address. Okay, so this will take close authority, which is just an address, and I will put the issuer's address here. Great. And then I can get the mint size, which comes as a number, and then I can create the token. How do you create a token? Well, first, you gotta create that account with the system program. So we would do a get create account instruction. We could do the allow prefund if we expect that there might be Sol on that account yet, but nah, nobody put some Sol on that account. I just created that key pair live, so I can do a normal create account. But this is just me promoting another video that I made because I found that quite interesting. And what we need here is the payer, so that's going to be my issuer. The new account is going to be the mint. We assign it to the token 2022 program, and the space will be the mint size. And Lamperts depend on the mint size, so let's get that directly from the RPC. Get minimum balance for rent exemption for that mint size as a big int. Send. Let's go. That's step one, creating the account. Then step two, we're gonna initialize all of our extensions. So get initialize default account state instruction. What does it need? The mint, which is my mint address, and the state. And here I provide the state, the actual data for what the state should be. Up here I could write anything, but here I actually provide it. So I provide account state frozen. That should be my actual default account state. Good. So with that, we have the default account state initialized. Then I'll also initialize mint close authority, which again will take the mint. Here you have it. And the close authority, I'll put the issuer himself. Good. Same thing here. This is just a placeholder. This is the real thing. Cool, so I initialized my extensions. Now I can actually initialize the entire mint account. So get initialize mint to instruction, because there's two different versions. We already looked at what the difference is. One doesn't need the rent sysva or whatever, and this is a token C. Just so it's the same as it is with token kek, they kept the same. So the mint, again, my mint address, the decimals, I can initialize it with however many decimals I want. For instance, 6. I feel like doing 6 right now. And the mint authority, I'll keep that. And now it gets interesting. The freeze authority. That thing we will need to set to the PDA of the ACL program. Should we do that right away, or should we first just create the token? Because if we're getting this wrong, we can, if we have the freeze authority, we can still transfer it. So for now, I would say I keep the freeze authority for myself. So this is now not working with any ACL stuff yet. This is just a regular token 2022 token with default account state frozen. So let's just create this token. npx tsx create token. Great, that worked. We created a token, which means if we check that address, we see it's a token 2022 mint with the mint and freeze authority still sitting at my issuer. And we have the two extensions of mint close and default account state. Great. Now I'm too lazy to do everything in TypeScript. I'm just gonna do it here. What's my address? I'm still the sub from yesterday. Cool. If I would SBL token create account for this token, that will work. I can create a token account for myself, but it will be frozen. We can also check it out here. This token 2022 account has status frozen, which means I can't do anything with that account. I would now need to tell the issuer, hey, please, can you unfreeze that account for me? So the issuer himself could also create himself a token account, which will also be frozen. So we can't even mint tokens because custom program error 0x11 account is frozen. So we can't mint tokens, can't transfer tokens, none of that. We first need to say SBL token thaw and then give you the token account, which I don't remember. Is it enough if I put the token? Nope, because that's not a token account. Damn it, accounts v. This is the token account. So this is what we need to thaw and then we can mint. Okay, and for the other user, the same, such that the sub can actually work with this account. I would need to SBL token thaw his account manually. Only then is it unfrozen, so initialized, and then it's good to go. Then I could SBL token transfer one of this token to this receiver. Boom. And then it holds a token. Wow, magic. So now that works as it would regularly with the token program, but every new token account that is created starts out being frozen, and that's on purpose, such that we will need to authorize them manually. However, we don't want to do that manually. We're like, oh, this is so annoying. I don't want to get all those requests from the users. I just want to say all the users that I know who are allowed, put them in a whitelist, or even better. Or maybe I would say it's actually just a few people that I'm concerned. It's actually just a few addresses that I'm concerned about. Let me do a blacklist instead. And this is the whitelist approach, right? All of them are blacklisted per default unless we add them to the whitelist. So let's do this. Let's start using token ACL. Here's the program implementation, but really I'm just interested in the client stuff, in the JavaScript client specifically, which I guess is being released as token ACL, and that will come in the token ACL SDK. What do we have in here? We have a bunch of stuff. Thaw create. There we go. Fetch, find, fetch mint config, find mint config PDA. That's what we want to do next, because we want to have our token mint delegate the freeze authority to this mint config PDA. So we need to find this mint config PDA. So find mint config PDA. What do you need? Just the mint. Well, that's easy. There you have just the mint address. So it's just one seed that it takes, or one dynamic seed, and that derives us our mint config. And then what are we going to do with this? Well, I think we got to create it somehow. So there's probably, what else is there with the mint config? There's codecs. No. Maybe I don't need to create that. Let's check in the example. Create the config. No, there is a get create config instruction. Oh, it's called create config, not mint config. Okay, so it's called get create config instruction. Right. Great. So that's what we'll do. That is an instruction to the token ACL program, and it will need the mint. We have that. The payer, who initializes this account, so I let the issuer pay for that. The mint config, that's what we just derived. That's the PDA. The authority, now that's going to be the account who can change that configuration, I guess? Or is it the authority that holds the current freeze authority? That I'm actually not sure. Should we test that? Because I would just provide the issue and it will be fine, right? But the issue is both the previous authority and the new authority. But yeah, everything in me tells me the pattern in Solana, usually if it's the authority, then it's the authority of the account that we create here at the create config. So it's the authority over the config. So it's a new one. So I would say I put the issuer. I don't think that this instruction actually changes anything on the token. It's just creating that config for that mint in that mint config. And that's the address paying for it. And the authority. Oh no, but the authority is a transaction signer. So it actually expects that we sign with this authority. So maybe the authority indeed is the current freeze authority. You know what? I'm gonna check that. I'll do a pseudo authority just for testing this. The pseudo authority will be my authority, which is not the current authority of my token or freeze or whatever. So we'll see if that works. But again, I want to find out if that authority is for that config or if it's an authority for the token. We'll see. And then the last thing we need is the gating program. So that's now the program that's responsible for checking whether an account can be permissionlessly thawed. And I'm gonna use the ABL, so that's from ABL SDK. So that's the reference implementation that will allow me to work with this. In a future video, I might create my own gating program, but for today, we'll just use the one that already exists. And let's see if I can create this ACL mint. Clear and run npx tsx create ACL mint. That doesn't work. Oh, 0x0. It doesn't give me more because the implementation of token ACL is efficient, but not developer friendly therefore. So I will need to look here in the program source errors and see what the first error is. Invalid authority. There you go. Okay, so this has something to do with the actual authority. You know what? I could also have just read the source code and check what create config actually does. There. If the freeze authority is not the authority, then we have invalid authority. Yeah, okay, great. So this authority must actually be the freeze authority of the token. It's not an authority inside, or is it? Let's check. Oh no, it stays the same. Config freeze authority is the authority key. And so we see that creating this config actually already transfers the freeze authority. So it's good that we didn't do it when we created that token, that we transfer the freeze authority here, because that is done by the ACL program itself when we call the create config instruction. So we don't need the pseudo authority here, we need the actual issuer. Thanks. Nice try. We don't need you. But with the correct authority, that should work. There we go. Let's look at that. So we created this one account, which is the PDA of the token access control list program, and it invoked the set authority for freezing that account. And the new authority is that account. So that's the config mint, or what was it called? Mint config PDA. So this is the mint config PDA. Could name it that. There, mint config PDA. And if we look at our token, we see that the freeze authority has now moved to the mint config PDA. The mint authority stayed the same, but the freeze authority moved. Great. Okay, so this is an actual ACL token now. But again, not much has changed. If some new person creates a token account, then it's also default frozen. And now we can't manually thaw accounts anymore, right? Because I don't have the authority anymore. So if some other user would create an account for this token, oh, they can't because they're broke. But if they're not broke, then SBL token create account for this should work. But obviously that account is once again frozen. And even me as the issuer, I set it back to my address, even me, I cannot thaw this account because owner does not match. And owner is again a really bad word, because really what this is, this should be freeze authority doesn't match. That's an interface source error 1 2 3 4. Owner does not match. Again, weird. Where's the implementation of this? So it's a process toggle freeze account to freeze false, and it checks the mint owner. Anyway, so I don't really understand why we get the owner mismatch error. But the problem is that I don't hold the freeze authority anymore, because that worked earlier, right? We could thaw the token accounts. This one, that's the token account of the user, but it's frozen. Right. So how do we now do it? How do we use token ACL and the gate program? We gotta enable permissionless thaw. Enable users to thaw their own accounts. Because per default, permissionless thaw is disabled. We saw that. Why did we see that? There. The default, neither the permissionless freeze nor the permissionless thaw is enabled. That's just the default of the create config. So we gotta enable that. Enable permissionless thaw. For the same mint config, we now get enable, wait, what's it called? Toggle permissionless instructions. It's a toggle permissionless instruction. So the permissionless instructions are the ones that you can toggle to allow them. So the permissionless instructions of the ACL program, you can toggle to enable or disable them. And that itself is an instruction to the ACL program. So here you go. This instruction needs the authority, which is my issuer. Freeze enabled. You know what? I can keep to false. I could also enable that. But the important thing is that I enable thaw. And the mint config is that PDA that we have derived earlier. Okay, so that's step one. That's just writing to the config. And obviously we could have done that in the same transaction in the previous step. But like this, we do it separately. So it's just another transaction that gives us success. Great, done. Such that users can now call this thaw. How do they do it? With the create thaw permissionless instruction with extra matters. This is where it gets complicated then. So let's do a thaw permissionlessly as the user. So we don't have access to the issue anymore, but the user. Okay, let's see what we need to get thaw permissionless independent instruction. Let's just do this. And that needs quite a lot. Needs the authority, which I guess is the authority, because obviously it's permissionless, so that the authority is just the user. So the authority on the whitelist. Side note, we didn't create a whitelist yet, so obviously this is not going to work first try, but we're going to work our way there. What else? The mint, well, that's somewhat obvious. That's the token mint address. System program, token program should be obvious. Mint config, we also have that derived. That's just the mint defined config PDA for that mint. The gating program we said was our ABL program address. The token account, that's the ATA of the user. So we just await find associated token PDA for this mint, this owner, and the token 2022 program. And then what else is missing? The token account owner, that's once again the user. Aha, so they split the authority who can unfreeze from the token account owner. So the token account owner doesn't necessarily need to be the same one as the one on the white. Is that what that is? That's what that kind of looks like. We don't need to sign for this. We don't need to sign with the token account owner, but it needs the token account owner. Okay, and then flag account. What could that be? Any. What's a flag account? Maybe it helps me to read the actual instruction. That's not helping. Why is there no implementation? What's this? What does potent even mean? An action, operation, or function that yields the same result no matter how many times you execute. So basically the whatever just means that if it's already thought, then it's like, yeah, whatever, it's fine. And with this one, it might fail if it's already thought, maybe. Right, so that's the difference. If is then if it's not frozen, then we're returning okay. And otherwise, if it's not idempotent, then it might fail somewhere where it says we can't thaw because it's already thawed or something. Can we quickly try that? Give me just 2 seconds. 2 seconds. If I say SBR token, create token, so we have this token now. Oh shit. First of all, program 2022, and secondly, enable freeze. So hawk, there we go, that token. Now we SBL token create account for this hawk token. And can we now SBL token freeze this account? Yes. And can we freeze it again? No. Okay. We have an invalid account state, and the same for the other way around. If I SBL token thaw that account, it works, but if it's already thawed, then that doesn't work. That's where the independent, what's the word? Idempotent. Idempotent? How do you idempotent or idempotent. Okay, good. So the idempotent thingy is for, we could call that without it failing. If it's already the right state, then it's fine and we just return early. Great. So that's that. That's the difference. But I could also have this, not the idempotent, but just the instruction. If I know it is frozen and I will thaw it myself, then I can just use that. Or I do the idempotent instruction such that it works. If it's already thawed, then it will also succeed. Great. But we got stuck at the flag account. What's the flag account? Flag account bump, flag account seed prefix, token account seed bump, and then allocate, assign, and initialize flag account. Oh, so is that just a flag for it was done? It's a flag account. It's just 1 byte. They don't store anything in there. And then they do Solana system program allocate 1 byte and then assign to this program. And then we set it to 1. So this is just a flag account where we store 1 byte. What does the flag account consist of? It has a flag seed prefix, a token account. So it just depends on the token account. So every token account, so it's kind of the state. We're setting it to 1. Okay. Oh, and then we thaw it, and then we clean up the flag account. We set it to 0 again. We resize it to 0. We assign it back to the system program. So this is just a temporary account. That's for some security reason, I think, that nothing can happen double or whatever. I'm not sure. Or maybe to signal to the gate program. Yeah, maybe it's some signaling to the gate program. Because we first write the flag and then we call the gate program. So the gate program will probably check that flag, that this instruction actually comes from this program, the token ACL program. There's a similar thing that was done. Was it with transfer hooks actually? They did a similar concept, but I think they wrote it directly in the account. I'm not sure. Anyway, so that's why they temporarily use this flag account. Great. So then it's just something that we need to derive and provide. We don't need to create that account. That's all handled by the instruction. Okay, good to know. So all we need to find is the flag account, and there must be a find flag account PDA. There we go, easy. And it just takes the token account, that's the ATA, there you go. And then we provide that flag account. Boom, done. Do you think we can permissionlessly thaw this now? I don't think so, because we're not on any whitelist, but we can certainly try and do npx tsx thaw permissionlessly. And how will we fail? With 3 from the tackle program, it tackles us. We can't do that because the gate program returns custom program error 0x3. And if we check the gate program has an implementation here. That's the token ACL gate. This program has errors, and error number 4 is 1, 2, 3, 4. Not enough accounts. Dang it. Damn it. Because the other one is invoking it with gate program, authority token mint, token account, flag account, and the remaining accounts. We don't have any remaining accounts. We probably need more accounts, but I don't see, I mean, system program, token program, it takes automatically. So this is not the right way to do it. And it's also not how they do it here. Here they use create thaw permissionless independent instruction with extra matters, and the extra matters is what I'm missing. So hold on. Is there also a, nope. So that doesn't work. Let's try the create idempotent. That's one hell of a name. Create thaw permissionless idempotent instruction with extra matters. Ugh. What a name. Doesn't take much, but oh wow. Send and sign. That's not what I want. I don't want to give you a send and sign. That, wait, there's, no. There must be something else. Hold on. What else is there? There is an independent instruction, and there's instruction from min. Wait, hold on. The create, that's not an instruction. That's a, it does it already. The get always gets me the instructions. But here it has an account fetcher. Let's see. Permissionlessly from a token ACL mint. And what else was there? With extra matters, including all extra matter account dependencies. I think that's what we need then, because the extra matters we're missing. Because not enough account keys. And we need an account receiver, which is a function to receive the account data for a given address. If the token account is being created in the same transaction, the function should mock the expected account data. Ha! Great. But the account was already created some other time, so it's fine. Okay, let's try this one. We await this. Hold on. Okay, so it doesn't take an object, it just takes the things one after each other. Okay. So we start with the authority. It's much more difficult to do autocomplete with this guy. It's the user. So that's that. Then token account, that's the ATA. Then the mint is the mint address. Then the token account owner is again my user. Then the program address of which program? Probably the token ACL program. Although maybe also the gate program. Let's check here. No, the token ACL program. And then the account receiver. So that's a function for the address where it gives me a maybe encoded account. And the way they did it is they created it like this. I guess you just need that because somehow the SDK needs to be able to fetch accounts. And if we're working with the kit, then we can let the kit fetch it. Basically, it needs to get access to an RPC. And wherever you have an RPC connection that and can fetch the accounts, you could also mock stuff if you know where it lives or put it somewhere, whatever. But that seems like a fair implementation, so I'm going to give you that. And then this is how it all looks like. There you go. And that should also give me the extra matters. You know what? I'm actually curious which account it looks up. So I'm gonna log that. And then let's try this. Let's thaw permissionlessly. Doesn't work. I almost would have expected that. Token transfer hook account not found. Why are you looking up the token transfer? Oh, is this just for when we do it with the transfer hook? So with that extension and transfer hook? Is that what we need the extra matters for? We don't have a transfer hook extension, so it's fine. But okay, it looked up the TD1, so that's good. The TD1, that was my mint config that indeed we didn't put anywhere here. Although no, here we put it. But for the extra matters, it looked up that account. Okay, and it did find those things, the gating program, the freeze authority. So from here, it probably read which gate program it's supposed to call. And then I guess from that it looked up another account. Which one? What's this one? Why am I logging this? And this one, it then failed. Token transfer hook account not found. We don't have a transfer hook. This is more complicated than I thought, actually, honestly. But it's complicated for devs, not for users. But it's still simpler than transfer hooks. I'm just confused as to what the exact accounts are that I need to put in. There's also, what else was there? There was a permissionless instruction from mint. What would that take? That takes directly the RPC, the mint address, the mint end address. Hold on, what's the mint then? Oh, you get, oh, if you provide, because if you provide the mint, then from the mint it can read the mint config. Let's try that. That would work like this. Fetch mint from token 2022 with an RPC, and the mint address mint info is this. So that's an account mint, but it's still something different. Mint info data gives you the mint. Okay, so that mint info is now the mint. That is what I would put here, so it can read the mint config from there. The mint address is mint address. Token account owner is the user. Token account address is the ATA. Payer shall be my user. I don't know why I need a payer. Oh yeah, transaction. Payer of the transaction. And then I can still say if I want it idempotent. Yes, I want. But does this now create me a transaction? No, also just an instruction. Returns instructions or instructions. No, promise instruction. Oh, this is not confusing at all. But it doesn't like the RPC. Oh man, doesn't like that. Okay, then that's also not gonna work. Besides, it would be pretty much the same as this. What is it doing differently here? I would like to look at the source code of this. What does it do? It finds the mint config PDA and gets that. That's what we saw. Okay. Then it finds the flag account PDA. Then it finds the thaw extra matters account PDA. Then get can thaw or freeze permissionless account matters. Then get thaw permissionless independent instruction. There it builds the instruction. Then it resolves extra matters with the account receiver, and then the instructions are the thaw account instruction accounts plus the matters, and we resolve extra matters. Where is that? From TVL. We also already talked about that. So it looks like in this step it's trying to get another account that it can't read from. So maybe that just means that the gate program didn't set up there. Because there, the thaw account extra matters, find thaw extra matters PDA from the gating program. Let's do that manually. All right, because it's a custom program, it can have any accounts, so we do the TVL. So there's one PDA with the extra matters that defines which extra accounts the gating program needs. And so that one account here, that's the one that it doesn't find. And the error with token transfer hook account not found is just we can't get extra matters. Doesn't have anything to do with transfer hooks. Transfer hooks is just the program that uses this functionality, so that's probably why it comes with this name. But really we create the thaw permissionless instruction extra matters, and we just get the extra matters. We resolve those, and that's where it fails then, I think. Okay, so anyway, let's check if that's actually the account it's looking for, because it's looking for a TCAV. Mint is my mint address. Does it take the program? I think I need to also provide the program address, which is the ABL program, and then I log this. Find thaw extra matters account. And that thaw extra matters, yeah, that's exactly that one that it's also trying to look up here, but then it fails because that account doesn't exist. Okay, so my gate program is not set up properly because it didn't create that account. So we first need to set up the gate. Set up gate. How do we do that? So there is a create account, create allow list, get create list instruction. Set up extra matters on both lists. There we go. Find thaw extra matters account PDA. That's what we are setting up here. Set up extra matters instruction. That's what we need to do first, of course. Otherwise the other thing just doesn't work. Or did I skip a step? Set up ABL gate program. Yeah, I guess I skipped that step. Lol. Oops. Yep, I did not do that. My bad. But now we learned what happens if you don't do that. There it's setting up the thaw extra matters PDA. Ah, yeah, with a get setup extra matters instructions. Easy. And then you can put your list or your lists. Right. So that's how we create the lists and then set up the extra matters that it finds those lists. All right. Okay, good. We can do this. It's a get create list instruction. Get create list instruction from BL program. So what does it need? An authority. I'll do that as the issuer. The mode of the list is a mode allow list. I'm just gonna do one allow list. And my seed is an address. So, and I think that's just good practice, but they say we should use the mint as the seed. And maybe it's not just good practice, but it's required. So I'll give you the mint address. And the list config, what could that be? Oh, that's a PDA. Okay. So the list config is a PDA that we find with list config PDA, and it needs the authority, which is my, and the seed, which is my mint. There you go. So that list config in here, and that's how I create the allow list, and then I create the extra methods for the gate program. That's what then actually allows it to be called, because that's how the ACL program calls the gate program. Yes, all a bit complicated, but watch my video on extra metas and stuff where we went through that, the TVL stuff. Setup, it was called setup extra metas instruction, this thing, which needs again the authority, which is my issuer, the mint, which is my mint, the token ACL mint config, that's the mint config PDA that I derived earlier as well. Then the extra metas, this is again something that I need to derive. The extra metas, it's a find thaw extra metas. So we can have separate lists for freezing and for thawing, which is cool. They're each just different things. So if we want to allow freeze as well, we need to also set it up with the extra metas account, and that will just need the mint address. So I put the extra metas, and then we put the lists. And this is now my list config. If I want to have several lists, I would just use a different seed, an allow list seed and a block list seed. So it's just a unique seed for a block list. Using the mint here as a seed is just good practice if you just have one list per mint, but you can use any address or any 32 bytes as a seed, just so you can have a unique list. Yeah. Okay, so where are we? We put the list config, we put the list and the lists here, and that's just a list of list configs. So I put my list config as one item. I just have one allow list. That's it. Okay, and like this, I set up my gate. Let's do it. npx tsx set up the gate. It doesn't work because also here we have 0x3. Also here we don't have enough counts, even already at the first instruction. Even the create list instruction does already not have enough accounts. This is more complicated than I thought. Create list, try from, and if we don't have authority pair list config system program, we have not enough account keys. And that was the error, right? 0, 1, 2, 3, not enough accounts. Authority pair list config system program. Authority, we didn't provide a pair and we didn't provide the system program, but that I would say it managed itself, right? This doesn't change anything. Nope. Could it be that I have an old version of, oh, this is annoying. Could it be that I just have an old version of this? I hate it when that happens. I really hate it when that happens. Or that this is just not up to date. The ABL SDK. Token gate version 0.2 and I have 0.2. Let's check the IDL instructions. That's the create list. So it has the authority, the pair, the list config, and the system program with that default value. So in the IDL, there's also the pair in here. But this thing, there's no pair. This is old, I guess. Yep. I hate it when that happens. TypeScript, source, generate, instructions, create list instruction, create list input. Here it has the pair. What? What did I import? So I guess PNPM just doesn't have the most up-to-date, like the NPM package is not published, the newest one. Okay, fine. So what do? We copy this, then we git clone this, and then instead of working with the token ACL ABL SDK, we're gonna work with local token ACL gate SDK TS source generated, or actually index. Do you think it will find the things there? It has most of the things. And now look, now it has a pair. Ha! Suck it. Now I can put the payer. And then this thing complains because lists must be an address array. And this thing is an address of a string in an array. What? Oh, lists does not exist. Hold on. You want addresses. It's now called addresses. No, also not. Hold on. Wow, I'm getting confused now. Should we just let's do it from the top. What do you need? You need the authority, which is my issuer. You need the mint, which is my min. You need the addresses, which is just extra matters. It just set up extra matters. So whatever extra matters are, I guess, just my list config, I'm not sure. The extra matters account is the one that we derived. The payer, this time it gets the payer as well, is the issue. And the token ACL mint config is that list config. No, wait, is the mint config there. There. This works. Look, with a more up-to-date... See, if I was an AI, I would have probably figured that out quicker than I did, but I did. I'm just slow. What did we learn? Well, sometimes if we get NPM packages, they might not be up to date. So anyway, with the payer added now in both of those instructions, does it now work to set up the gate? No, it still doesn't, but with a different error. At least the first one actually worked. The set up the list actually worked, but then set up the extra matters didn't with 0x9. Oh, great. What's that? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Invalid extra account. Invalid extra matters account? Wait, what's the extra matters account supposed to be? Program source instructions. Set up extra matters. Invalid extra matters account. If extra matters is not extra matters from find program address, variant seed and mint. So the extra matters now need variant seed and min. Okay, so there might be a new extra matter. So the find thaw extra matters. Wait. There's find freeze and but that's from here. That might also have changed. Or, wait, is there a get setup? So now there's just get setup freeze, there's get setup extra matters, and there's get setup freeze extra matters. So it's no specific thaw anymore. I'm pretty sure that you could just throw an LLM at this problem and it will fix it in a few minutes, but damn it, I want to do it myself. I want to still know how things work. I'll get there. Don't worry. Find thaw extra meta PDA. Oh, I know. I need to find thaw extra meta PDA, not with that mint. We did it earlier, but I didn't. Man, it's supposed to be with the ABL program. Oh, man. Yeah. I had the wrong program that I derived this extra matters for. Obviously, I need to derive it for the gate program. Okay, but like this. Hands in the air. Woohoo! Finally. See, then if I do it myself, I'm happy that I managed. Nice. So we set up this account now, finally. This extra matters account and this list. We created this list. That's the list. And so that's my list config PDA. And then later we set up the extra matters, and that's the extra matters thaw PDA, because for freezing there's a different one. Okay, great. But we didn't enable freeze, so it should be fine. Now that we created this, does the permissionless thaw work as well? Wait, the thaw permissionless. Thaw permissionlessly. Does this work now? No. But how far do we get? We do get further. Look. We first look up the TD1, so that's the mint config. Then we look up the TCA, which is the extra matters. And then we look up the DKO, which was my mint ATA. This is the ATA of the user, because from the ATA it then finds the mint config. No, wait, it had the mint config. I don't know, it just looks up that as well. Okay. And then it invokes the tackle program, which creates accounts and then invokes the gate and then failed to pass validation for list. Oh, great. No, but that actually means it works, because we get a 0x2 from the gate program, which is account blocked, aka the account is not on the whitelist. That's great, so that works. Because that account is not on the whitelist. It should not be able to thaw permissionlessly. Okay, so how can we get it on the whitelist? As the issuer, my list config was this, because I still remember the seed, which was my mint, and I created that list, but now I need to somehow add to that list, or get add wallet instruction. I think that's it. Add wallet. What does it take? The authority, my issuer. The list config, we have that. The wallet we add, that's my user. So my user, that's the owner of this token account, for instance. There. The owner of the token account is gonna be my user. Here you go. So wallet is the user. Wallet entry. Okay, what is this? I don't have a type for that. T wallet entry. Okay, wait, what else? The system program. So that's it. I add a wallet. That's the authority to this list. That's the wallet I add. And wallet entry, what could that possibly be? If you don't know, you read the source code. It's an account info, so therefore it's an account. Oh, wallet entries looks like a PDA. Oh, so that's, you create a list by creating a PDA. So it's a map. It's not a list, it's a map. It's a hash map with PDAs. So the wallet entry is just a PDA that takes the list and the user wallet. From that you derive an address, and that's then the wallet entry, and then you can just check the wallet entry. Yeah, that's how it's done on Solana, working with PDAs. That's the nice way of working with PDAs. We discussed that one time before as well already, or several times, because we don't just store the user account into a long list so that we then need to look through that list. That's stupid. We can work with PDAs. Just put it as seeds. So the seed will be wallet entry, prefix, the list config, and the wallet. That's what I said. There we go. And then the bump. Easy. Okay, so we just gotta derive this. It's just gonna be another PDA. So wallet entry will be find wallet entry PDA for the following list config and the user wallet. Yeah, I need to define the user before that. There we go. That way we have the wallet entry, and that way adding this should work. So that's how you add a wallet to a list. Let's see if that actually works. Add to the whitelist. Oh, nope, didn't work. Oh, once again, the 0x3, we didn't have enough accounts. Because add wallet, because it took it from here again. No, don't do that. You can have the ABL program address from here, fine, but not those two. Those two you take from there, and then we will need to provide a payer, because that's new. The user can pay for it, that's fine. Oh, actually, wait, no. The user can't pay because the issuer gotta pay. The user is just the address. And then that is also called differently. It's not wallet address, it's wallet. Great. Yeah, there you go. And I hope that at the point where you work with this, the NPM package got updated to the newest things and you don't need to grab them from GitHub. But yeah, that's just, if you work with new tech, you gotta get used to things not being up to date or whatever. So yeah, but hey, that's why it's good that I do that manually, and that you also learn what the issues are, because sometimes, most of the cases, your AI will fix that for you and there's no problem, but sometimes your AI will get stuck, and if you have no idea what you're doing whatsoever, then you are stuck as well. Me, I don't need AI, I just need time to figure it out. Okay, add to whitelist, boom, worked. I added it to whitelist, score. And now that we added this guy to the whitelist, can he thaw permissionlessly? Yes, he can. Look. He called the thaw permissionless, which temporarily created this account with 1 byte. Then the gate program was called with the correct extra matters and list and so on. And the gate program returned OK, which allowed the ACL program to thaw the account. Very nice. Very nice. That's cool. And there's so many more things that we could check here. The can thaw permissionless that got called from the ACL. I just want to quickly look how I want to find the flag account. Validate thaw list. Or does it not take the flag account? Maybe what I said earlier was wrong and the flag account is not passed through the gate and it's used for something else. Could also be. Okay. That's so cool though. And maybe we were a bit fast here. First, we created this wallet entry, this one. That's the wallet entry PDA. And with this entry, the unfreeze was possible. So we added that. It's just an entry of 65 bytes. And actually, we can now conveniently look at this here. Look, what would be in here? I don't know, some address and some other stuff that it saves. I don't know, I'm not 100% sure what it saves, but it saves some stuff. But with that account, because that account exists, and probably because it has certain data written in it to cross-check, the actual thaw worked because that token... wait, can I look at this raw? Yeah. If we look at it raw, then we see also the extra account matters, and the extra account matters. So the first ones are just the authority mint and so on and so on and so on, token program, system program, gate program. And then afterwards, there's extra accounts. So after the gate program, there's the extra account matters. So the extra matters for thaw. And what the extra matters are is the list config and the wallet entry PDA. Those two, it needed to put as extra matters such that it can give it to the gate program, this one there. We gave those to the gate program such that the gate program can say, yeah, I authorize this, the thawing of this account. Pretty nice. Okay, it's been a long video again. Conclusion, token ACL, pretty powerful, but also pretty complicated. And there's so much more here. For instance, there's a CLI, right? You can do all of what we did today with the kit. We can also do it in CLI. You can play with that if you want. There's also that fun thing with the token helpers for auto thawing, where you can create and confirm associated token account, which automatically thaws the account if it's such an token ACL token. For that, we would need to put an extra token ACL key into the metadata of the token and write the gate program in there. We didn't do this today. Our token didn't have any metadata, but I leave that as homework for you if you want to play with that. I just enjoy most playing with low-level instructions, so calling instruction per instruction. The fewer helpers I actually need, the happier I will be, personally. But that's just me. Some people also like it if it just works out of the box. Which for this thing, honestly, it was complicated, but it did work in the end. So I'd say I'm happy with that. What a journey. Pretty cool, huh? That we can have an allow list without requiring transfer hooks. Again, it's similar technology. It does also require two other programs. It's not trivial. It does add overhead and it's certainly compute extensive compared to a regular token like Token CAC, because Token CAC is just so efficiently implemented. Token 2022 isn't, and with all those CPIs, it is heavy on compute, but therefore you can do proper KYC and AML, and you can have block lists, and you can have a combination of block and allow list, and you can disallow PDAs, and you can even write your own program that does custom checking whether a wallet can thaw or freeze. And maybe I'm gonna implement such a program myself in the next video. Let me know if you're interested in that. Leave me a comment. Also, while you're here clicking stuff, do click that subscribe button if you have not done that already. Like this video if you enjoyed it. And there's much more to explore. Here's some more. This will be the one about the gate if I made that video. And then I will see you in the next video exploring more stuff. Because yeah, there's programs being developed and I want to check them out such that we understand them and not just our agents.